The cell in which the following reaction occurs: Fe3 plus aqueous plus I minus changing to Fe2 plus and I2. E0 cell is given. Standard Gibbs energy has to be calculated and equilibrium constant value has to be calculated. The reaction taking place in the cell is Fe3 plus 2I minus forming Fe2 plus I2. These are the aqueous solutions and I2 is in solid state. Now the formula for delta G, standard Gibbs free energy, is minus NF E0. F is the Faraday's constant, E0 is the standard EMF of the cell, N is the moles of electron involved in this cell reaction. Now how to find the moles of electron involved in the cell reaction? Fe3 plus is changing into Fe2 plus. So iron in plus 3 oxidation state is changing into iron in plus 2 oxidation state. So there is decrease in the positive oxidation state, means this is reduction, and the change in oxidation state is 3 minus 2, that is 1. So how many electrons are involved in the reaction? 1 electron. Fe3 plus will accept 1 electron and it will change into Fe2 plus. This is the reduction half reaction. Now 2I minus changing into I2. How many electrons are involved? Now I minus plus I minus changing into I2. Each atom of iodine has minus 1 oxidation state. It is changing from minus 1 oxidation state to 0 oxidation state in iodine. So change in oxidation state per atom, change in oxidation state per atom is from minus 1 to 0, that is 1. Therefore, change in oxidation state for 2 atoms of iodine will be 2 into 1, that is 2. For 1 atom it is 1, for 2 atoms it will be 2. Now for change in oxidation state of each iodine atom from minus 1 to 0, the number of electron lost is 1 electron. Now when 2 iodide ions change into iodine, the total number of electrons lost is 2 electrons. Now in this reaction, when iodide ion changes into iodine, the change in oxidation state is from minus 1 to 0. So there is increase in the positive oxidation state, therefore this reaction is oxidation half reaction and it will involve loss of electron. So 2 iodide ions changing into iodine with the loss of 2 electrons. The number of electrons lost can also be obtained from total change in oxidation state. The total change in oxidation state is 2, therefore the total number of electrons lost is also 2. So this reaction where Fe3 plus ion changes to Fe2 plus ion, this is reduction reaction, and the reaction where 2I minus change to iodine is oxidation reaction or oxidation half reaction. Now on adding these two reactions, redox reaction is obtained. This is the redox reaction obtained which is given in the question. But before adding these two reactions, the number of electrons lost should be equal to number of electrons gained. So number of electrons gained by Fe3 plus ion is 1 electron and number of electrons lost by 2 iodide ions is 2 electrons. To make the number of electrons equal, the reduction half reaction will be multiplied by 2. So this reaction becomes 2Fe3 plus 2 electrons forming 2Fe2 plus. Now the number of electrons is same, and on adding these two reactions, half reactions, number of electrons on the reactant side will cancel the number of electrons on the product side. The overall redox reaction is 2 electrons lost by iodide will be accepted by 2 Fe3 plus ions and they will change into 2 Fe2 plus ions. So this is the cell reaction which is obtained, and here the number of electrons involved is 2. So value of N is 2. It can also be said that number of moles of electrons involved is 2. Now putting the value of N and solving, this will be minus 2 into 96500 into E0 value is 0.236 96500 coulomb per mole is the value of Faraday's constant. Solving, the value of delta G will be minus 45,548 joules per mole. Now this can be converted into kilojoules. Just divide it by 1000. So this becomes minus 45.55 kilojoule per mole. Now delta G is also equal to minus 2.303 RT log K, where K is the equilibrium constant. So using this equation, log K is equal to minus delta G divided by 2.303 RT. Value of delta G is minus, and value of delta G is also in negative, so minus 45,548. This value is in joules divided by 2.303 into 8.314. This is the value of R into 298. Solving, the value of log K is 7.983. Value of K will be equal to anti-log 7.983, which is equal to 9.616 into 10 to the power 7. So this is the value of equilibrium constant. Value of log K is 7.983. Therefore, K is anti-log 7.983, which is equal to 9.616 into 10 to the power 7.